our session. Yeah, so very good afternoon, all of you. In today's session, we will see multiple regression. So, in previous week, we started with curve fitting and regression analysis, and in that we begin with the need of regression analysis. Then we fitted the given data set to a straight line, and we also understood what is the need of regression analysis and how it is taken care of while especially solving the problems related to uh, curve fitting for uh, two parameters that we considered, x and y, where y was dependent variable and x was independent variable. Now, in this particular session, we will be focusing more on multiple regression. So before we start, briefly we will recall the need of developing empirical laws. So we discussed that in engineering, mathematics, social science, in most of the applications, we collect so much data, and from those data we need to find out the relationship between input and output. And once we get the relationship between input and output, or between two different variables, then we can use that empirical law or that relation to make some predictions, to take some decisions, and so many things can be done with that relationship. So we saw these two examples, but we will briefly review those examples. Suppose we want to develop a relationship between the strength of a material and how it varies with respect to the temperature. So what you will be doing, you will be checking the strength of that given material for different temperature, and accordingly you will be developing a relation, the variation of strength with respect to variation of strength with respect to temperature. And once you get the relationship, you can make various decisions. For example, for a given operating temperature, what will be the material, suitable material, and what will be its available strength, and you can pick up a correct material for a given application at given temperature. Again, from this table, where the speed of water jet in a turbine and corresponding efficiency of the turbine is given, and once you develop the relationship between these two, you can actually design a turbine for a maximum efficiency of the turbine in which we are interested. So in both these two cases, one common thing is that there are only two variables. In first example, temperature and ultimate tensile strength, these are the two variables, and we are interested to find out the relationship between them. And in second example, speed of water jet and efficiency of turbine, these are the two parameters. Now, in regression analysis, we have seen, and this is one of the figure I have taken from the Steven Chapra book, where on y-axis you will see a force, and on x-axis you will see a velocity. And for force and velocity, these are the different data points that we plotted on the graph paper. And once you plot by using a least square technique, you draw a straight line. So you can see a black color straight line. So that line is drawn in such a way that the distance between the curve and the points will be as minimum as possible. So that care we have taken while drawing the straight line, and we know that the least square regression will help in this regard. So this is the significance of the least square regression. But now this particular example or two examples that we saw in previous slide, one question comes. whether the output, for example, in this case force, or in case of previous examples, the efficiency of turbine or the strength of the material, is only dependent on only one variable, one parameter. For example, force is dependent only on the v, velocity, or in these two cases, the strength only dependent on the temperature, or efficiency dependent only on the speed of water jet. So that point we need to understand, or we need to think on whether the output depends on only one parameter. In actual life, the answer is no. So for example, if you take an efficiency of a turbine, that depends on the speed of water, of course it will be dependent. Again, it will be dependent on the turbine blades, and over the period of time the turbine blade will get deteriorated, and ultimately it will affect on the efficiency of the turbine. Again, you can think about one more parameter, that is the foreign particles or the contaminants available in the water, that will also affect the efficiency of the turbine. Ultimately we can see that the quality of the water. Again, there are so many other factors that will affect the efficiency of the turbine. Now, what we did in this case, for simplicity purpose, we consider only one parameter, that is speed of water jet. But in actual life or in real example, what is your role as an engineer, that you need to find out a list of parameters that will affect the efficiency of the turbine. And once you identify those parameters, try to identify the impact of each parameter on the efficiency. Once you understood the impact of each parameter on the efficiency of the turbine, you will say, sir, out of these 10-20 parameters, only 4 or 5 parameters are significant, and they affect a lot on the efficiency of the turbine. And once you understood this concept, what you can do, you can select only these 3-4 parameters, and you will develop the relationship between these 4 independent parameters and the efficiency of the turbine as dependent parameter. So such type of examples you need to understand. We will take one more example. You might have seen a lathe machine. Okay, so what is done in lathe machine or CNC lathe machine? A job or a bar is mounted on the spindle, and there is a cutting tool, and with the help of that cutting tool we give proper shape to the job which is mounted on the spindle. And now in that process, the cutting tool is very important, and especially its life, because that cutting tool comes continuously contact with the workpiece, and the material is removed from the workpiece. But at the same time, the material of the cutting tool also get removed, right? And when that material removal takes place at the cutting tool, that will directly affect the quality of the job that is to be manufactured, and it will also affect on its tolerances. So therefore, what is very important in this case, the important thing is that what is the useful life of the cutting tool. Here two terms are there, life of the cutting tool, and along with that I am adding one more term, useful life of the cutting tool. What is useful life of the cutting tool? The duration for which the cutting tool will manufacture the job in such a way that the job will be ready with desired tolerances. And the life is dependent on, the life of the cutting tool is dependent on the cutting speed V. So you can see, and this is the general relationship, that is equation number 1, is widely used in machine tool industries to find out the life of the cutting tool. And equation 1, as I told you, is very popular. And in this equation, V is cutting speed, T is cutting tool life, then N is coefficient or exponent, and C is the constant that is estimated for the given application. So with this relationship, we can find out the life of cutting tool for different cutting speed. So when you look at this equation, you can easily guess that, sir, this is the exponential type of equation, and if we take the logarithm on both sides and if we simplify, you can convert this non-linear equation to a linear equation. Y is equal to a plus bx. In that form we can convert, and you can, if the data is available with the cutting speed and for that corresponding tool life, you can easily find out the what is the life of the cutting tool for different cutting speed. Now we use this equation very commonly, but do you really think that the life of the cutting tool depends only on the cutting speed? The answer is no, and the correct equation could be the equation number 2. This is equation number 2. So here the very important thing is that along with cutting speed, the life of the cutting tool also depends on speed, which is denoted by S, and it is also dependent on depth of cut. So these three parameters are dominating parameters, and that will affect the life of the cutting tool. So for simplicity and understanding purpose, we can go with equation number 1, no problem. Or for a given cutting feed and depth of cut, you can go with equation number 1. But in actual machine tool industry, different operations on the job is carried out. Turning, facing, drilling, so many operations. And for each operation, we need different operation needs to be carried out with different cutting speed, with a different feed rate and different depth of cut. And when you come across with all these things or all these parameters, you must go with equation number 2 in order to find out the life of the cutting tool in a better way or accurately, I would say. So that's why what I would say, as an engineer, whenever you are working on a different systems, so you must find out which are the different parameters that will affect the life or efficiency or any other desired parameter. Once you identify the parameter, find out the relationship between these parameters. Once you get the relationship, the last question is, how will you utilize that result or equation for a given application? So what could be the possible use of such relations or results obtained from the relations is, you can select a suitable cutting tool for a given speed, feed and depth of cut. So as an engineer, you can make that decision. On other hand, if you know the machine is to be operated for a range of cutting speed, a range of feed and range of depth of cut, then again you can select a group of cutting tool for which you can get optimum life. Third thing is that if you know the life of the cutting tool, then appropriately you can decide a range of cutting speed, a range of cutting feed, and a range of depth of cut. So on both sides you can make use of such equations. So both things you can do, either to improve the life of the cutting tool, that decision you can make, or if you know the life of the cutting tool, then you can select these variable, the range for these variables. So there are n number of situations and n number of things that you can do. And even here I will give you one idea. So, and that you can do for this mini project as well. For example, you select a particular cutting tool. Once you select that cutting tool, then for a given machining operations, you can run the machine for different speed and find out its corresponding life. Once you get that relationship, and again you can expand it for the different parameters, and once you get that regression analysis, you can write a paper that for a given tool and for given manufacturing operations, these are our important results, and through that result the user will be in a position to find out the optimum cutting speed, feed, and depth of cut to get the job with the desired accuracy or quality, and vice versa. So that kind of research work or a paper you can write. And if you go to the different research papers or journals, you will find out n number of research paper published on this such kind of work. Okay, now we understood that every time we should not go with the linear regression. Many a times you should go with the multiple regressions. Briefly, multiple regression means we are considering more than two parameters to develop the relationship between those input and output. So for our syllabus, we are restricting our study to this particular equation in case of multiple regression, where y is your dependent variable. Why I'm saying y is dependent? Because it is dependent on x1 and x2. So that's why y is a dependent variable and it is dependent on x1 and x2. And y is dependent on x1 and x2 means, again there are two variables x1 and x2. We call x1 and x2 as independent variables because they are not dependent on each other. And here we are assuming that x1 and x2 are independent. As I already mentioned, y has a linear relationship between with x1 and x2. Here we are not saying x1 square or x2 cube. It is only x1 and x2. So that's why we are considering y has a linear relationship with x1 and x2. And we are using the experimental data to fit this particular straight line. Now we will move ahead, and here as a part of our syllabus we are restricting our study to two independent variables x1 and x2 and one dependent variable, that is y1. So as a part of our syllabus we are restricting this, but in actual case that number of independent variables will be more than 2 as well. Now the very interesting thing is that on a graphical way how that represented, because in case of only two parameters x and y, we were taking one y-axis and one x-axis and we were just plotting the points and we are drawing a straight line for regression analysis. But here there are two parameters x1 and x2. So on this, in this figure you can see there is a one axis for dependent variable, that is y, and two more axes, one for x1 and second for x2. These are the two independent variables. So the picture become three-dimensional. And when you plot the points y and corresponding x1 and x2, then it will become a plane, not a straight line. So you can see a square or a rectangle here highlighted by a red color. So ultimately you are plotting the points in a plane. So here, in case of multiple regression, in this particular case, instead of straight line, you will get a plane. Means what you have to do, you will have three coordinates y, x1 and x2, y, x1 and x2, and by using the data points, you need to plot these points. So you can see each point will have three coordinates, one in y direction, one in x1 direction, and one in x2 direction. So we plot these points, and for these points we draw a plane, not a straight line. We draw a plane in such a way that the distance between the plane and these data points will have a minimum distance. This is very important. What I'm saying, we are drawing a plane, you can see in the figure, in such a way that the distance between that plane and the data points that we plotted must be minimum. And this is also called as multiple regression. And one more thing, you can see that the black colored points that you can see on your screen are above the plane, and there are a few more points you can see here, 1, 2 and 3. These are the 3 points which are below the plane, and we draw a plane in such a way that the distance between the plane and these data points must be minimum. And our role is to find out the coefficients A, B and C such that there will be a case of least square regression, and in this case least square multiple regression. Now we will move ahead. I guess you understood how we plot the points by using 3 coordinates x1, x2 and y, and then instead of a straight line, here we need to plot a plane because we are dealing with 3 planes, and we find out the coefficient A, B, C in such a way that that will be the best fit plane for the given data point. Now in order to find out these coefficients, optimum values of these coefficients, so for that there is a big derivation. I'm not going to that derivation. For more details you can refer Steven Chapra book, in that derivation is given. And once you simplify that derivation, you will come across this particular matrix. And for the given data sets means the values of y, x1 and x2, you will have these data points, and from that data points you need to find out the value of n. N means total number of data points, summation of values of x1, summation of x2, again summation of x1 square, summation of product of x1 and x2, then summation of x2 square, summation of y, summation of x1y, summation of x2y. So you need to prepare a table. From that table you need to find out all the values of the matrix, and when you look at this matrix is of A x is equal to B. So such type of thing we already studied in unit number 1, solution of simultaneous equations. So from that table, or you will be preparing a table, from that you will be calculating all the elements of matrix A, all the elements of matrix B, and by using those matrix A and B, you will be finding out the values of A, B and C of matrix X by solving the simultaneous equations. So once you solve, you will get the optimum values of A, B and C. So this is how we solve the problem by using multiple regression. So briefly, once again, I will take a review of this and then we will go to the example. So in multiple regression, in our syllabus, we are restricting to y is equal to a plus bx1 plus cx2, that equation. Here, y is dependent variable and x1 and x2 are independent variables. And we will have a data points. By using those data points, we will plot those points on the 3D plane where you will see y, x1 and x2 are the three axes. You will plot all the points. Once you plot all the points, what you will do, you will draw a plane in such a way that the distance between the plane and the data points will be minimum. And for that, we will be using the least square technique. And by using that, we will find out the optimum values of coefficient A, B, C by using this equation A x is equal to B. And we already know that how to solve this matrix. For that, first of all, we prepare a table. We find out the elements of matrix A and matrix B, and then we solve the simultaneous equation. Now we will take one example. Use multiple regression to fit the following data, where you will see in the table the values of x1, x2 and y are given to you. And here the equation is not mentioned, but we know that the equation will be y is equal to a plus bx1 plus cx2, as there is only one dependent variable and two independent variables. And once this is the case, then this is the matrix that you have to use and find out the unknown coefficients A, B and C. And once you put those values in this equation, you will get the required equation for y. Now what we will do, we will carefully prepare a table so that we will get the values of from matrix A and matrix B. Okay, so let's go ahead. So in column number 1, you will see the values of y, 5, 10, 9, 0, 3, 27. In column number 2, you will put the values of x1, 0, x1, this one, 0, 2, 2.5, 1, 4 and 7. In column number 3, you will put the values of x2. That you need to do carefully, because during that process you may put wrong values. So that's why carefully put the values of y, x1 and x2. Then when you look at the matrix, you need to prepare a column which will calculate the values of x1 square. So square of 0 will be 0, square of 2 will be 4, square of 2.5 will be 6.25. So this is how you will prepare the column number 4. In column number 5, what you will do, you will take square of x2. So here it is x2, so square of 0 is 0, square of 1 is 1, square of 2 is 4. Similarly, you can prepare the column for the values for x2 square. In next column, what we will do, we will find out the products of x1 and x2. So you can see here the product of 0 and 0 is 0. The product of 2 and 1 is 2, and so on. You can find out the remaining values. In next column, we will calculate the values of x1, y. So that you can see here. So we can calculate the values of x1, y by taking the multiplication of value of y and x1. So 0, 20, 22.5, 0, 12, 189. So you can see here the product of 27 and 7 is 189. So this is how you can prepare second last column, and last column you will take a product of x2 and y. So once you take the product of x2 and y, you will get the values first 0, then 10 into 1, it will be 10, and so on. So while preparing this table, you need to check this matrix very carefully and verify that you have prepared table in such a way that all the unknowns from the matrix can be calculated. For example, x1, yes, x1 summation of x is there, summation of x2, yes, summation of x2 is there, this is there, summation of x1 square, so you can see summation of x1 square is there, summation x1 x2, so summation x1 x2, this is there, summation x2 square, so you can see here summation x2 square, then summation y, you can see summation y, then summation x1y, summation x1y, and finally summation x2y. So yes, in table we calculated most of the values from the matrix, and the last value is n. N is the number of data points. So here in the table you can check how many data points are there. 1, 2, 3, 4, 5 and 6. So number of data points equal to 6, so n will be 6. Now we can say that all the values from the matrix A and matrix B are now available with us, and now we can calculate the values of A, B and C. So here you can see we put all the values of matrix A and matrix B, and now we have to calculate values of coefficients A, B and C. Now when I look at this matrix, then we have seen such type of matrix while solving the problems related to simultaneous equations. So here I'm not going to tell you how to solve this matrix Ax is equal to B. You need to do at your own and find out the coefficients A, B and C. So upon simplification, you will get the value of A as 4.85, B as 4.09 and C as minus 3.04. Once you get these values, you can put those values in the equation of y, and when you put it, you will get y is equal to 4.84 plus 4.09 x1 minus 3.04 x2. So this is how we solve the problem and prepare the desired or required equation. So once again, I will quickly take a review how to solve this problem. First, you need to check the problem, what is asked and what data is given to you. Once you understand that, write down the equation for the multiple regression from the data points. Once you write the equation, write the matrix equation that we saw in previous slide. Once you write the matrix, prepare a table in such a way that all the values from the matrix will be calculated in that table, and that you need to cross verify as well. Then along with that, just count how many data points are given to you. Once you count that number of data points, you will also get the value of n. Then put all the values that you prepared in the calculated in the table in the matrix, and once you do that you will get the simplified matrix. When you look at that simplified matrix, you can easily solve that and calculate the coefficients A, B and C by using any of the method that you studied in unit number 1, that is a solution of simultaneous equations. Or if you know any other method, you can also use that one as well, but always prefer numerical method. And once you apply that numerical method, you will get the values of A, B and C. Once you get the values of A and B, A, B and C, put that into the equation and you will get the equation for Y, and that will be your solution. Sometime along with this, what may ask, find out the value of Y for x1 is equal to 3 and x2 is equal to 24. That question may be there. So just put the values of x1 and x2 in this equation and you can calculate the value of Y. So this is how we use multiple regression to derive the relationship between dependent and independent variables. So that's it from my side. If you have any question, the session is open for discussion. Yes, any question from your side, you can ask.